Hello, I'm Michelle Hobbs, and this is going to be the, um, sorry, I'm opening up the exam 2 practice questions. Let me just make sure I get the right one. Practice questions. Here we go. Okay. And I'm going to share my screen. Oh, excuse me. Okay. Hmm. Share. There we go. Oops. Sorry, I'm just getting set up. Okay. All right. So this is just me attempting to do the practice exam, practice questions part 1. And I'm going to go ahead and open it up. Okay. State whether the variable is discrete or continuous. The number of cups of coffee sold in a cafeteria during lunch. Let me open this. Oops.
What is binomial experiment? So far, we talked about different types of variables, everybody. We talked about continuous random variable, and we also said what is a discrete random variable. For a discrete random variable, we went over probability and how to calculate probability. Now, for a discrete random variable, we might have a special case, which is called binomial experiment. So what is a binomial experiment? A binomial experiment is a probability experiment, satisfies the following conditions. What are the conditions? First of all, the experiment has a fixed numbers of tries, where each trial is independent of the other one. It means that the outcome of a trial has nothing to do with the next trial or previous trial. Two, there are only two possible outcomes of interest for each trial. Each outcome can be classified as a success, S, or as a failure, F. The probability of a success is the same for each trial. And finally, the random variable X counts the number of successful trials. Very good. So if you have experiment, probability experiment that satisfies these four conditions, we call it a binomial experiment. The symbols associated to binomial experiment are as follows. Is the probability of failure of success not that counts the number of tries. How do we introduce these symbols? What is the probability by these as x? Two factors on what the binomial experiment. Patients in this surgery. So you have fixed, know that we have fixed numbers of tries.
Okay, sorry, I was trying to open up a video about, oop, that's describing this question. State whether the variable is discrete or continuous. The number of cups of coffee sold in a cafeteria during lunch. So I believe that this would be, just looking back at my notes, would be, whoops, discrete. It doesn't say to write why, but because it represents a count of whole, like countable items, the cups of coffee, and it cannot be measured like continuously. So that is my explanation for that. Next. Oh, excuse me. Oh, sorry. Okay. So question 2, state whether the variable is discrete or continuous, the height of a player on a basketball team. I believe that this one is continuous. Because the height can take on like any value within a range rather than being limited to like specific distinct values. Mm. And then for the next question, let's see here. State whether the variable is discrete or continuous, the cost of a statistics textbook. Um, this one is gonna be, sorry, I'm yawning so much. Full-time job. The cost of a statistics textbook is gonna be, um, I think a continuous variable, making sure I'm spelling that right. Continuous because it can take on like again any value within a range. So like that would include like prices with like decimal values, so that would be within the cost of a statistics textbook. And then we're doing another one here. Um, State whether the variable is discrete or continuous, the speed of a car on a Los Angeles freeway during rush hour traffic. Um, Let me think here. I'm wondering if it is discrete because no, I think it's continuous. I think it's continuous because again, it's taking on like any value within a range again. So this would be like the range would be um the speed of the car. So continuous for that one. Um and then like oops, no period. The range, the speed of the car can be like expressed as a fraction or a decimal because you can write out like the miles per hour. So that's a good way to remember that. Next. Oops. Okay. Excuse me. Okay. Hmm. Excuse me. Assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability of exactly find the probability of exactly 9 boys in 10 births. Is this binomial? Binomial probability or normal probability? Oops. Let's see. Let me open this up real quick. I'm gonna need some help with this one.
Remember that for binomial probability distribution, P of x is defined as n factorial divided by x factorial n minus x factorial p to the x q to power n minus x. But again, this formula is already built into your calculator. You don't have to use paper and pencil to calculate the probability. All you need is to identify the keyword and use your calculator. Before using the calculator, reset your calculator. Turn on your calculator, click on second plus. Set 2 things. Now you have to read. So you don't have any built-in function in a particular surgery is performed on 8 patients. The probability of success is 90%. Suppose now the question says, hey, I want to know what is the probability that I have at most, calculate A, the probability of X be exactly equal to 6. What's the meaning of that? When we see something like this, the interpretation is what is the probability of exactly 6 successful surgeries. The keyword given to you is equal to or exactly. When you have keyword exactly, it directly refers to binomial PDF. Probability density function. To use that function, you need to click on second vars. Second vars. And then find binomial PDF. So second vars, and you need to move through these functions to find binomial PDF. Binomial PDF for me is located here. Enter. Now, when you click on binomial PDF, we need to enter some information. The number of tries. The number of tries n, we know that we have 8 patients. This is the number of tries, 8. The second one is P, the probability of success. We know the probability of success is 90%. This is my P, probability of success. I'm going to enter it using decimal, everybody, 0.90. And finally, it says, what is your X value? My X value is 6. So let us enter 6 here and calculate the probability. Remember that for binomial probability distribution, P of X is defined as n factorial divided by x factorial n minus x factorial p to the x q to power n minus x. We have an example here. The example says a particular surgery is performed on 8 patients. The probability of success is 90%. Question says find the following probability.
Sorry, I was trying to find the example for this question so I could follow along. I don't think that's the right one. Try to find it.
Probability and real experiment of a truly the reasons the proposed success. This is basically infinite numbers less of equations. And then experiments. Directly having to solve when you plug in champion. So we again resolve your PDF. So when you click in the comma, what is case scenario?
That is not it.
Now this question says find the probability steps second. This is 62 digits. Point thing. So the probability 0.7 or 15.7%. But if the question says, hey, round it to 2 decimal, it is point AB or 16. Remember that for binomial probability distribution, P of x is defined as n factorial divided by x factorial n minus x factorial p to the x.
Trying to find your video. Hmm. All right, well, I'm gonna go ahead and try to just look at my notes and solve this. Is this a binomial probability or a normal probability? I'm gonna type that it is binomial. And that is because each birth for this question would be an independent trial with two possible outcomes, boy or girl. And then what function would you use on your calculator? Let's see. I think binomial PDF. Um, just checking my notes. Find the probability of exactly 9. Um, what function do you use on your calculator? Binomial PDF or binomial CDF or normal CDF? Um, I think I wrote binomial. Yeah, I think binomial because it is a binomial probability. And then N would be the number of the trials. So exactly 9 boys in 10 births. So the N is the number of trials, so it's going to be 10 because there's 10 births. And then the value of X is going to be um the number of boys. So that's 9. And then find the probability of exactly 9 boys in 10 births would be uh, I'd have to calculate that. Um, oh, excuse me. So find the probability in 10 births. So I think it would be type as dot. So I know that it's going to be, let me read it one more time. Assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability of exactly 9 boys in 10 births and then type it as a decimal. Find the probability of exactly 9 boys. Hmm. Assume that male and female births are equally likely and that the birth of any child does not affect the probability of the gender of any other children. Find the probability. Find the probability of exactly 9 boys in 10 births and write it as a decimal. Okay, so using the calculator, the probability. So let's see. it would be, the fraction would be 5 over 512. And then converting that to a decimal, calculate that, and then, okay, round the decimal to 3 decimal places. I am getting point. Hopefully that's right. Okay, I think this is the correct one now. So let's see.
Remember that for binomial probability distribution, P of x is defined as n factorial divided by x factorial n minus x factorial p to the x q to power n minus x. But again, this formula is already built into your calculator. Is performed on 8 patients. The probability of success is 90%. What is binomial experiment? So the simple or 1 times x times binomial experiment. Question says find a problem. Now this question says find the probability that at least 2 of them respond yes. So what's the meaning of at least? It says, hey, x is more than or equals to 2.
At least 2 of them respond yes.
Binomial function in your calculator, you need to follow these steps to find the probability that x is at least k. So first you need to type in 1, then subtraction, binomial, CDF, n, p, and k minus 1. So take a look. We type
Binomial
in 1,
CDF,
subtraction,
binomial CDF, as it says here.
Binomial, take a look. CDF. I'm not working with binomial PDF.
Binomial CDF, so that's why I typed that.
CDF. So hit enter. The number of tries you ask 4 people, right? So it should be 4. P, the probability of success is 62% or 0.62. Now the x value is not 2. The x value is 2 minus 1. I have to do a little bit of algebra and then hit paste, and you find the probability to be 0.843. If the question doesn't say anything about rounding, you're going to type with 3 digits, 0.843. If it says, hey, round it to 2 decimal, you get 0.84. So that depends on the question. Let's go back to our lecture note. Again, the probability that x is more than or equals to 2 is the probability of 2 plus probability of 3 plus probability of 4. If you add all of these together, you get 84.3%. And if the question says, hey, round your decimal to 2 decimal place and write it as 0.80, you get 84% or 0.84. This is the answer that you're looking for.
Okay, so that is why I wrote binomial CDF, because that's what was put in the calculator. It's a binomial problem. This is asking for 3 decimal and 3 numbers, so that's 0.843. And then let's see, find the value for n is going to be the value for n. So looking at this problem, binomial CDF parentheses, n is here, p, k minus 1. Oops.
Let's make it more interesting. So far we found the probability that is exactly 2, which was 33.3%. We found the probability that it is at least 2 following the function here. Now the question says, hey, find the probability that it is fewer than 2, less than 2. Find the probability to hit enter. We type in 1, subtraction, second, vars, and you need to find binomial. Take a look. CDF. I'm not working with binomial PDF. I need to work with binomial CDF. So hit enter. The number of tries you ask 4 people, right? So it should be 4. P, the probability of success is 62% or 0.62. Now the X value is not 2. The X value is 2 minus 1. I have to do a little bit of algebra here and then hit paste and you find the probability.
So the value for n is 4 because it's showing right here. That's the first number. All right, next. Okay, find the area of the indicated region under the standard normal curve. Let's open this up.
What is a normal distribution? A normal distribution is a continuous probability distribution for a random variable like X. The graph of a normal distribution is called the normal curve. A normal distribution has the following properties. First of all, the mean, mode, and the median are basically the same. The normal curve is bell-shaped and it is symmetric about mean. The total area below the normal curve is 1 or 100%. So 100% the graph is just the behavior of the curve or the function. We can use mean plus 1 standard deviation, mean nicer section. These 2 points on the horizontal line are at mu plus sigma and mu minus sigma. So now that we introduced a normal distribution, we are interested in analyzing standard normal distribution. There are infinitely many normal distributions, but we are interested in standard normal distribution. Z-scores or using standard normal distribution. It happens that the mean becomes 0 and the standard deviation becomes 1. The horizontal, the standard deviation to get your, when you are in a cell. The most important part in dealing with either normal distribution. First scenario is second, vars, and you need to find not normal PDF, but your cursor must be at 2, which is normal C, D, F. So again, what I did, second, vars, normal CDF.
So I'm writing normal CDF, normal because it's a bell-shaped normal curve.
Area is on the left-hand side of 1.23. But on the left-hand side of 1.23, you have 0, you have some negative numbers, and it continues to the left-hand side. On the left-hand side, you have negative values. You can leave this as this small number, or you can change this into, so you're going to use a negative sign. The negative sign is going to be this sign inside parentheses. -10, -100, something very small. Again, the question says, find the area to the left side of Z. Z is given to you as 1.23. Any number less than 1.23 is going to be on the left-hand side. So on the left-hand side, if you go further to the left, it's going to be a small negative number. For simplicity, you can use -10, -100, -1,000. No one's stopping you. As long as you're using a negative sign, you are fine. Upper limit. Where does it stop? It stops at 1.23 on the right-hand side. So 1.23. And what is the mean? Mean of the standard normal distribution is always 0. What is the standard deviation? The standard deviation or variability is always 1. So if you're working with z, these two numbers are fixed and they stay the same. So go to the next line and then hit enter. Hit enter again. So if you're using your TI 83 or if you're using your calculator on your phone, calculate 84, you have to type in everything this way. Normal CDF, open parenthesis, the lower bound, which is -100, comma, the upper bound, which is this number here, 1.23, comma, 0, which is the mean, comma, 1, which is the variability or standard deviation. Hit enter, and as you can see, the area or the probability is 0.89065. But if you were to round it to 4 decimal places, since you have a 5, you're going to add 1 to 6, so it becomes 0.8907. So this area is 89.07%, or in decimal form, 0.8907. So again, either in decimal form or in percent form. When you're talking about probability, you're talking about this shaded region. The second scenario is usually asking you to find the probability on the right-hand side of Z. So for Z on the right-hand side, suppose you have the following information. Question says, the area to the left of Z is 1.23 is 0.8907. This is what we calculated. Now, what if I ask you to find the area on the right-hand side of 1.23? Well, what are you going to do? We're not going to use a table. Table is very old-fashioned. 0.23, the right-hand side with Z 10 to Z scores. So here, the Z-score on the left is in your calculator, clicks 1.23. And since you're dealing with Z, bounded between these two numbers is 1%.
Okay. So we'll find the probability or the area below the curve. So I'm getting 0.0968, but this is only wanting 3, so 0 or sorry, point 0.97.
What is a normal distribution? A normal normal distribution is a continuous probability distribution for a random variable like x. The graph of a normal distribution is called the normal same. So when you're, it means that the balanced standard deviation for
This is the same
every
video.
set way
Let
that
me pull up another example because that is
probability,
helpful.
or another word, the area. Whenever we talk about the probability, you're basically talking about the area below the curve. You have three different scenarios. The first scenario is find the area to the left side of x or to the left side of z. Okay, in this case, z is given to you as 1.23. The area to the left is going to be this shaded area on the left-hand side. So let me use my calculator and show you how to deal with this probability and area. Let me share the screen so you can see the calculator. So click on second vars, and you need to find not normal PDF, but your cursor must be at 2, which is normal CDF. So again, what I did, second vars, normal CDF. Click on normal CDF. Take a look. This area, all and one
I need to look for the right.
if you were form
To the right.
bars, and you're going to find your normal CDF. Your cursor must be at normal CDF. Now, your lower bound on the left-hand side is 1.23. So change this to 1.23. On the right-hand side, the graph, this shaded region, the blue area, continues to the right-hand side. So start at 1.23 and goes to where? A positive number. You can use 10 or you can use 100 or any large positive number. Remember that as long as you're dealing with z, mean is always 0 and standard deviation is always 1. Go to paste, hit the enter, and you get 0.1093. What's the meaning of that? It means that this area is 10.93. There, click second vars and find normal CDF. Your lower bound is negative 0.75. So negative 0.75. And your upper bound is 1.23 on the horizontal line. So you're looking at this little piece on the horizontal line, 1.23. For z-score, mean is always 0 and standard deviation is always 1. So again, since you're dealing with z, you have to keep these fixed as 0 and 1. Then you go to paste, paste again, hit enter again, and as you can see, the area is 0.6640, or the probability that z is bounded between these two numbers, or mu. So these are all on the horizontal minus sigma. Every data analyst refer to the way that are incompetent, but to mean. You have three different areas, but on the left hand 1 point, so if your bound is 80, on the right goes right in the area bounded between.
This is what I need for this one here. So let's see. Find the probability or the area below the curve. The area to the left is negative. The area to the left is um area to the left uh, is going to be from the notes negative 0.45 and then subtract the area to the left, and then the area to the right is gonna be 2.11. Oh, let's see. So I'm getting a pretty big number, 0.6562. So I'm just gonna do 0.656. Mm, Okay, so let's get rid of these here and open up this one.
It takes 1.5 years for people to buy a new cell phone. Am I right? The standard deviation is 0.25 year, and then your job, your goal is to find the probability that the user will keep the phone for less than X. Oh no, the graph keeps going. Remember the positive numbers mean the phone. The upper limit is going to be if the question doesn't care. Comes to our help.
Oops.
I got used to the feeling of it takes 1.5 years for people to buy a new cell phone. Am I right? The standard deviation is 0.25 year, and then your job, your goal is to find the probability that the user will keep the phone for less than 1 year before buying a new one. Okay. We have some indication that this distribution is a normal distribution because it says the lengths of time people keep their phones are normally distributed. Okay, so how do we find the probability? Let's take a look at our board.
So I think, let's see here. Find the probability. So this is going to be normal. Ouch. Okay, this is a little bit different than the sample. So it is, let's see. The lengths of pregnancies of humans are normally distributed with a mean of 268 days and a standard deviation of 15 days. Find the probability of a pregnancy lasting less than 250 days. Is this binomial or normal? Um, since this is, oh no, my computer's dying. Since this is a continuous variable, like a pregnancy length, it's going to be a normal distribution. And then, so we're going to use normal CDF for that. And then we're finding the probability lasting less. So my calculation is It has to be two numbers, decimal, two numbers as a percentage. So find the probability. I already got that as 0.1151. So I need to turn that into a percentage. So that would be 11.51%. And I need to make sure my computer's not going to die. Oops, 7%. Okay, I'm almost done. Let me grab my charger real quickly. Oops. Sorry. Okay. Grabbed the charger. Sorry about that. All right.
Find probabilities for normal distribution. In this example, a survey indicates that for each trip to supermarket, a shopper spends an average of 45 minutes with standard deviation of 12 minutes. The length of time spent in the store are normally distributed and are represented by variable x. A random shopper enters the store. Find the probability that the shopper will be in the store for each interval of time and interpret the answer when 200 shoppers enter the store. How many shoppers would you expect to be in the store for each interval of time listed below? So first, I want to find the probability that the random shopper spends between 24 minutes to 54 minutes in the store. And then what is the probability that the random shopper spends more than 39 minutes in the store? So first of all, take a look at the information and the graph associated to 1. Between 24 and 54, you're looking at this little interval here. 24 and 54. And again, below the curve, you're going to shade this region. Mean is 45. That's how you see the balancing point. With standard deviation, which is 12 minutes. You can either use your calculator to find a probability for x value, which is 50. And using your calculator, if you are dealing with z, you're going to enter z, but make sure you enter correct information. Second bars, and find normal CDF. The lower bound is negative 1.75, so negative 1.75. Upper bound is 0.75, so 0.75. Mean for z is 0. Standard deviation for z is 1. So if you hit enter twice, you get 73.33%. However, if you decide to use x, it doesn't matter. You get the exact same probability. Second, bars, go to normal CDF. The lower bound is going to be your minimum x value, which is 24. So type 24 and upper bound is 54, maximum probability. Try to use X%. This is the area below 100. For more than 39 minutes, you are looking at the shaded area on the look at your graph. The lower this probability, the probability that a random shopper spend more than 39 minutes in the store for this shaded 9, and another deviation probability that a random shopper spend more than, how many shoppers would you expect to be in the store?
All right, so let's see here. So for this one, the distribution of cholesterol levels in teenage boys is approximately normal with a mean of 170 and a standard deviation of 30. Levels above 200 warrant attention. Find the probability that a teenage boy has a cholesterol level greater than 200. All right, so I said this was normal, and then we're going to use a normal CDF in the calculator. And then let me do my calculation. Oh, Sandy. All right, so I am getting the z-scores calculated, finding, so the probability is 0.1587, and then you multiply that by 100. So then I'm gonna get 15.87%.
Percent. The question is, well, how can I use this probability 10% and find the z associated to that 10%? Let me go to the board and explain that for you. We have the probability. Again, guys, when you're talking about the probability, we're talking about the area below the graph. You have the probability. You can use the probability. Functionality that you're going to use is inverse norm. You go to vars, and then you're going to use the inverse norm. Inverse. So again, a quick recall for you. Quick recall.
Invoice norm. So I put that there.
The probability that X is less than
and this is a normal
distribution.
Distribution.
You're going to go to second. You're going to go to vars, and you're going to use normal CDF. Then you have your lower limit, which is like -10, -100, a very small number. You're going to have your upper limit, which is A, the mean, and you have your standard deviation. If it says, hey, the probability that X is low, your upper limit is a lower limit. But this case is different. you have the probability. This number, this value is given to you. You can use the probability to find your z. After you find your z, then you can find, well, x value becomes this a little bit more. X is 4, x is z times sigma plus. So we know that it must be top 10%. Top 10%, where is that located? Let's take a look at your graph. This is my graph, top 10%. Top 10% is going to be here. 10% of 100%, but it is top 10%. Top 10%. Okay, so what is the z value for top 10%? What is this z? So first we need to find z, then we're going to find our x value. Let's use our calculator. To find z, you're going to use your inverse norm. So go to second, vars, inverse norm. Inverse norm, well, the area is 10%, okay? So the area is 10%, 0.10, and the mean is 0 because you're trying to find your z.
Mean is 0.
Mean is 0 with standard deviation 1. So 10%, 0.10, mean is 0, standard deviation is 1. Let's do the paste. The number that is written here is negative because it gives you the z value on the left-hand side. The calculator computes the area to the left. So since mean is 0, the z, which is mirror image of negative 1.28, is going to be positive 1.28. Okay, it wasn't that hard. I used second, vars, inverse norm. The calculator computes a negative z-score, which is the mirror image on the left-hand side, negative 1.28. But since I have the top 10%, this is the below 10%, the lower 10%. This is what your calculator has inside it. It's built into your calculator. Lower top, lower area, lower 10, into a positive 1.2. So you know that x is equal to sigma times z times sigma, and the mean is 50. 50 to it, you get 62.8. So this is the minimum score that still be considered.
Okay. And I got, let's see, I'm all done here. Okay. All right, and that is my practice part 1.